So session 2006, exercise number 1, horizontal mechanical oscillator. We start with this exercise by reading the given. So consider a mechanical oscillator that's formed of a solid S of mass 0.1 kilogram, and you have the constant of stiffness is K. S is move without friction, so it's the mass without friction with its center of mass on the x prime x-axis. An apparatus is used to register the position of the center of mass G at successive instants separated by constant terminal interval tau equal 20 millisecond. It's shifted in the positive direction. So this means I have, for example, so let's suppose I have, this is the system, and it's shifted from its origin toward the positive direction, and then it's released without initial velocity at the instant t0 equal to 0. And the above apparatus gives the positions g0, g1, g2, g3 of the center of mass at the instant t0 and till many instants. And you have here in the table the different position of the center of gravity g of the object during its motion. And you notice that here is the origin O. So we have OG0, we have OG1, and etc. Now, we start by reading the question. At the instant t, the abscissa x is the algebraic value of it, and its velocity is v. Write the expression of the mechanical energy of the system, oscillator, and Earth in terms of x, v, m, and k. And you have the horizontal plane so here is the gravitational potential energy. So here is the reference. So in order to write now the mechanical energy, we know that the system is the oscillator and Earth. So the mechanical energy of the system is equal to the kinetic energy plus the gravitational potential energy and the elastic potential energy. But since I'm here, so it's half mv squared plus mgz plus half kx squared. We know that we are on the reference. This means the height is equal to 0. So this is 0. At any instant, we will have the mechanical energy is of expression me equal half mv squared plus kx squared. In the part 2, derive the second order differential equation. We know that there is no friction. So عرفنا أنه that there is no friction means I can use the principle of conservation of mechanical energy. Me is conserved. When we say me is conserved, means me is equals to constant, which means that its derivative must be equals to 0. So in this case, I will take, this is the equation here in terms of at any instant of the mechanical energy. So I'll do its derivative. So if I do the derivative of me, it will be 0. The derivative of half mv squared, it will become half 2 mv v prime and plus half k also to x prime. Since we know that v and x are expressions, so this means it's as if I'm using u to the power n as derivative, it will give us n u prime u to the power n minus 1. So here we also know that v is the derivative of x dx over dt, and we also know that we have v prime, so a is v prime, which means it's x double prime. The v is different than 0 at any instant, so here we can, for example, substitute. So instead of x prime, I can put v, and instead of v prime, I can put x double prime. We simplify by the 2, and we simplify also by the v. So here I have v, and here I have a v. Since it's equal to 0, so okay, I can do the simplifying. So I get as answer mx double prime equal to 0. We can divide by the mass to have the expression of a second order differential equation of the form y prime plus ay equal to 0. So this is the second order differential equation. Now, the solution is given by x equal xm sine omega 0 t plus phi, and you have, these are the constants, xm, omega 0, and phi. Means the object is moving and as function of time with this position. At each time the time is changing, the position of the object is changing along this equation. So in the part A, the question is determine the expression of omega 0. We know that x is a solution. Phi is solution. Since it's a solution, this means it verifies the differential equation. So let's write our differential equation. Our differential equation was this. Now, we notice we have x, but we still need to find x double prime. So I will write here x. And then in order to find x double prime, I must find x prime first. The derivative of sine is a cosine. So the a is omega 0. So I get here omega 0 xm cosine omega 0 t plus phi. Now another derivative, the derivative of cosine is minus a sine. So I'll get minus xm omega 0 and another omega 0. So it will be omega 0 square sine omega 0 t plus phi. Now we have x. We have x double prime. Now we can do the substitution. So let's substitute in the differential equation. So this was the differential equation. And we'll do now a substitution. Minus xm omega 0 square sine omega 0 t plus phi plus k over m xm sine omega 0 t plus phi, which is equal to 0. Now here, I can take a common factor. So xm sine omega 0 t plus phi, this is a common factor. And I still have minus omega 0 square plus k over m equal to 0. Now, which means that omega 0 square equal k over m. وهيك بنكون طلعنا the expression of omega 0 in terms of k and m. In the part B, the question is determine the position of g. So when I say determine the position, I need to find x equal how much, for which the speed of s is maximum. So I need to find v maximum. The condition is v maximum. So for v maximum, I need to find x is how much. Now, so the condition is here. So I must start by here. Now, what is v? We know that v is equal to x prime, and we already find it. It's here, okay? So it's equals to omega 0 xm cosine omega 0 t plus phi. Now, my condition is that I need v to be max. For the speed, for the velocity here to be maximum, this means I need all this expression to be maximum. We know that omega 0 and xm are constants. So هما في يغير فيهم شيء. So for the v to be maximum, this means that the cosine must be maximum. This must be maximum. But we also know that cosine alpha is between 1 and negative 1. So I want the cosine to be maximum, which means that I need cosine omega 0 t plus phi to be equals to 1. This is the condition here. Which means that, so هيدي كلها I can name it مثلا alpha. Which means that cosine alpha equals to 1. This means that alpha equal to 0. For alpha equal to 0, I have cosine 0 is equals to 1, so this is the maximum value. هيدا بيعني, which means that الألفا هي مين أخذناها؟ omega 0 t plus phi هي كلها سميناها alpha. So must be equal to 0. طيب. This is the condition. This condition for v to be maximum will give us this equation. But our aim is to find x at the end. So هاجي اكتب لكان ال x xm sine omega 0 t plus phi. So what is the position for v to be maximum? For v to be maximum, I need cosine to be equal to 1. So I need alpha to be equal to 0. So I need all this to be equal to 0. So I get as answer xm sine 0, which means equal to 0. So the v بتكون maximum لما ال x تكون 0 يعني على position of equilibrium. And this is logic. So here we did the calculation, but by math calculation. So we verified it by math calculation. Let's continue now, part C. Applying the principle of conservation. So when we have the method A, natural method, okay, show that V maximum square is equal to V square plus all this. Now in the part C, so I need to do the conservation of mechanical energy. The system is the oscillator and Earth. Now, in order to do the conservation, this means I need to do ME equals to ME. Which two ME I should take? Here, it's at any instant. There's no precise instant. So راح أقول at any instant t. بينما هون, which means for any x. بينما هون, I need V to be maximum. And I already know in the previous part that V is maximum for x equals to 0. So this means when the object is at equilibrium, at the origin at O. So هون راح اخذ ME for x equal to 0. When I say ME at any instant, يعني for any x. Okay, what do I have here? KE, so I write all of this, plus GPE, plus EPE, plus EPE, equal كمان KE plus GPE plus EPE. We know that GPE is equal to 0 since I'm on the reference. Now, for x equal to 0, there's no EPE, there's no compression or elongation. So هيدي اللي هي half kx square, x is equal to 0, so راحت. So I still have half m, but here at x equal to 0, the speed is maximum. So I write here maximum square and equal KE, it's half mv square, it's any instant, and EPE, it's half kx square any instant. We notice there's no k in the equation that we have to reach, but I also know that omega 0 square is equal to k over m, which means I can substitute k but by omega 0 square times m. هلا سايفين نيجي نعملها substitution here. So we'll get as answer half. Okay, I'll do it here. So I'll get here as answer half mv maximum square equal half mv square plus half k. Now محل k I can put here, okay, omega 0 square m times x square. Okay, I just did a substitution. Now here I can simplify by the half and m. So هيطلع عندي as equation at the end v maximum square equal v square plus omega 0 square x square. هيك بنكون وصلنا لنتيجة. Now in the part 4, the question is, using the above table, show that the speed at t3 is equal to. In order to find the speed, so v3, which is an instantaneous speed, so I'll take the point just before and after, which means I'll take g2, g4 over 2 tau. Now, if I look here, so this is g2 and this is g4. I don't have in the table directly this value, but I have OG4. Okay, this is O, and I have OG2. So in order to find this value, G2, G4, I can say it's equal to OG2 minus OG4, لأنه we have the values, the origin بالعكس حطنا, it's here and not from this way. So over 2 tau, I have the values, but I have to pay attention, it's in centimeter, so it will be 8.09 minus 3.09 times 10 to the power negative 2 and over 2 times 20 times 10 to the power negative 3 لأنه كمان we have it in millisecond. So we get as answer in this case equals, so I will get here as answer equal to 1.25 meter per second. This is part A. Part B now, the maximum speed, using the table also, find that the maximum speed is this much. Now, in order to find the maximum speed, we knew that the maximum speed is for x equal to 0. So for x equal to 0, يعني I need to find v here at this position, which means it's the same as if I'm finding v5. So part C, I need to find v maximum. But v maximum is for x equal to 0, which means it's here at the origin. So v max is the same as v5. And I can say that v5 is g4 g6 over 2 tau. So كمان this is g4 g6 هيدي كلها. In order to find it, so I will do OG4, but this time plus OG6, okay, as value. أو if بما إنه we have it a negative, I can say minus and minus, so it will become plus. مهم إنه آخد المسافة كلها, okay? So I can write it in this way. I can say it's OG4 plus OG6 without taking into consideration the minus over 2 tau. So I will get OG4, which is 3.09 plus OG6 3.09. So لاحظوا I didn't take the minus لأنه أخذت المسافة كلها. Or I can say x minus x. So it will be x4 minus x6, and I will take in this case the negative, but I'll get the same answer. So times 10 to the power -2 over كمان 2 times 20 times 10 to the power -3. So we'll get as answer, it's 1.545 meter per second. So هيك بنكون طلعنا ال V maximum. Now, at the end, the question is deduce the value of K. هلا بما أنه أنا صار معي هيدي equation, so I can use the equation in order to deduce the value of K. I'll do it. So here, I'll put the equation. طلعت معنا equation V maximum square equal V square plus omega 0 square x square. Now, the question is to find K. So I have to take a certain point. V maximum معي إياها. So we have V maximum is 1.545. Sorry. So 1.4545 square equal. Now, if I want to take V and X, لازم اخد ال V with X corresponding. So let's suppose, for example, I took the value X3, which is equal to 5.88 centimeter. So I need to take V3. هلا ليش أخذت هيدا البوينت؟ لأنه كان سألنا عنه بالبارت اللي قبل. So I have it. So V3 equal 1.25 meter per second. So I have this particular point and I can substitute. So 1.25 square plus omega 0 square, and X is 5.88 centimeter يعني times 10 per -2, and all of it square. So from here, I can get the value. So حيطلع عندي omega 0 equal 15.44 radian per second. يعني we have all the numbers, but we know that in order to find K, so I know that omega 0 square is equal to K over M, which means K equal M times omega 0 square. We have the mass, it's equal to, كانت معنا إياها at 0.1. Okay, so we'll get here 0.1 times omega 0 square, 15.44 square. And then we get the answer 23.85 Newton per meter. So I told you have to pay attention that the parts are all related to each other. And when we ask about V3, or this means I have to use it. Now, my God, if for example حالة تاني اختار point تاني معناتها لازم يكون مطلع كمان ال V اللي لها. So here, that's it, and this is the answer.